I put up here on the board an adjusted schedule. So if you remember, I gave you a syllabus and I said I'd give you some grades for this so that we're sure how everything was going to go, right? And the timing of everything. So here's my plan for this week. Today we're going to do 5-4, which is what I anticipated. Tomorrow we're going to work on quadrilateral proofs. Wednesday and Thursday, we're going to wrap up quadrilateral proofs. It's going to be some review. Thursday review, Friday test. Okay, so that's the plan. Good? All right, so today what we're going to do is we're going to talk about mid-segments. So I rearranged the chapter a little bit. So I thought this would be a nice thing to kind of come back to. Kind of ease you into being back in school because this morning was brutal getting out of bed. Not gonna lie. All right. All right, so today we're going to talk about something called mid-segments. And you have learned about mid-segments before, but it's been a little while. So let's review what a mid-segment is. We look at mid-segments in terms of triangles. So a mid-segment is a segment that connects a midpoint of a side to a midpoint of a side in a triangle, is where the way we look at it. We did this when we did constructions. So we were doing the perpendicular bisectors to find the midpoints, and then we drew a segment from midpoint to midpoint. That segment was called the mid-segment. Okay? There are also mid-segments in trapezoids, but there's only one. You only join the midpoints of the legs to create a mid-segment. And so in a trapezoid, there is only one mid-segment. For triangles, though, I have one drawn in, but keep in mind, I could find the midpoint of this missing side here, right? And I could draw in 2 more mid-segments. So there are a total of 3 mid-segments in every triangle. Okay, so every triangle has 3 mid-segments. Every trapezoid only has 1. So what we're going to do is we're going to look at the property of mid-segments in relationship to triangles and trapezoids. We're going to start with just triangles. All right, so the mid-segment of a triangle, there are 2 properties I want you to think about. First of all, the mid-segment is parallel to what's called the third side. Okay, so it's parallel to the third side. So 2 sides are used to make the mid-segment, right? You have to have a midpoint and a midpoint. Those are the 2 sides that make the mid-segment. The other side is not used. It's called the third side. Okay, the mid-segment and the third side are parallel to each other. Now, that being said, if we have parallel lines and now we have transversals, keep in mind that you're going to have corresponding angles that are congruent, right? And then we also have lines, or angles between the parallel lines. So, for instance, angle 1 and 2 here, those are same side interior angles. So those have to be supplementary. Right? Remember that? Okay. Or keep in mind this red angle up here and angle 2, those 2 make a linear pair. So just kind of keeping that in the back of your mind. The other property that happens with mid-segments is that the mid-segment is half the length of the third side. So if AB is x, DE here is going to be half of an x. Or if you want to reverse it, you can say x to 2x. It doesn't really matter. Okay, so the mid-segment is half the length of the third side. All right, so we have parallel lines, and we have relationship between the mid-segment and the third side, being that the side is twice the length of the mid-segment. Good? So let's take a look at a couple problems using those ideas. So it says FG, GH, and HF are mid-segments. Okay, so a lot of times in mid-segment problems, they're not going to mark the triangle for you because it makes the triangle way too congested. Like, it's just too messy. So you have to know if FG is a mid-segment, that means they have bisected each side, right? Or those 2 sides anyways. And then if HF is a mid-segment, that means they bisected this side as well. All right, so that being said, we know our telling us that FG is 9, GH is 7, and CD, this whole length here, is 24. I want to find the measure of each missing segment and the perimeter of I said the triangle. We're going to find the perimeter of triangle CDE. We're going to find the perimeter of triangle CDE. So first of all, we're missing the length of one midsegment, right? So think about the side that it's parallel to. We know that midsegment has to be half. So what does SH have to be equal? 12. Good. All right, so now let's look at side CE. It's the third side to which midsegment? The 7, right, or GH? So if GH is 7, what does CE have to be? 14. And then what does ED have to be? 18, because we have 9, and so this would have to be 18. Let's also think about, just to make a point here, if CE is 14, that means each half has to be 7 and 7, right? And then we have 9 and 9 for side ED, and for CD we have to have 12 and 12, right? Just because it is bisected. Okay, good. So now we need to find the perimeter of triangle CDE. So I would need to take 24 plus 14 plus 18. Let's add it together. 52, 56, right, 56. Yep. What's another?
I also said 52.
Oh. All right, questions on that? All right, here's our next problem then. So we got to think about the relationship between the midsegment and the third side. So there's two ways to split this, or to write this problem, to solve this problem. I like one way better than the other, but I'll show you both ways. So we have the option, we would need two midsegments to equal the third side, right? So I would take 2 times the quantity of 6x plus 31 to equal my third side, which is 19x minus 36. Okay, so 2 midsegments equal the third side. Or what you could do is say that the midsegment, which is 6x plus 31, is equal to half of the third side. Honestly, I would choose the one on the left because I don't want to have to do decimals. Not that it's overly difficult, but I don't need a calculator then for sure. Like if I have to end up dividing by decimals, I want to double check myself. So I would err on the side of not having to do decimals, especially on a Monday back break. Right? All right, so I'll do the one on the left, but again, it doesn't really matter. So I would have 12x plus 62 equals 19x minus 36. Then I need to subtract 12x from both sides. I end up with 7x. Add 36, I have 98. Divide by 7, I have x is equal to 14. And again, you'll get the same thing if you do the other side, or do the other equation. But I didn't have to get a calculator out of them. Is that okay? All right, the last example we're going to do in triangles involves angles. Involves on the angles. So keeping in mind, I have a midsegment here, and I know that because I have a midpoint at angle 4 and 5 there, and I have a midpoint right here. So that is a midsegment. So we have to remember that we actually have parallel lines. Right? We have to remember that we have parallel lines. All right, so give me one of our angles. Anybody find an angle? Okay, we know 1 and 2 are ultimately going to be congruent, right? Because they are corresponding. Right? They're in the same position along the transversal. They're both on top of a parallel line. Or bottom, however you want to think about it. Okay? So how am I going to get, let's say, angle 2? Right, that's a linear pair. The 127 and angle 2 make a linear pair. So what's 180 minus 127? 53, which makes angle 153. Okay? Now what can I do? Okay, so how can I work on 5 and 4? Good, they're corresponding again, right? 59 and 4 are corresponding. So we know that has to be 59 degrees. So use my linear pair again. What do I get for angle 5? 121. Is that okay? Okay, now we need angle 3. So keep in mind, we actually have 2 options here. We could look at, hold on. We could look at this triangle here, because we're just missing one angle, right? Or we could look at the big triangle. It doesn't really matter, right? Because they all have the same angles, and they all still have to add 380 degrees. So we already have, what, 112? So 180 minus 112 gives me, should have 68. Is that okay? Okay, so we put some things together there. But we're going to add one more thing to this. We're going to add one more thing. It's, our book calls it the 3 mid-segment conjecture. But it's saying if you were to draw in all 3 mid-segments, what happens is you actually create 4 congruent triangles. Okay, you end up creating 4 congruent triangles. So let's think about why that is. So keep in mind, we know, let's talk about this mid-segment first. Okay, so I'm talking about this mid-segment. This side is my 3rd side. Correct? And we know, let's say this was 10, this would have to be 5. This is 20, this would have to be 10. Right? So let's say if this is 20, this would be 10 and 10, which would make this 10 as well. So because it has 3 tick marks, this would need 3 tick marks. Does that make sense? Okay, now think about this mid-segment here. How many tick marks should this one have? 2. This one should have 1. Okay, so now look, by side, we have 4 congruent triangles. Does that make sense now? Like how that all works out? All right, so that's our mid-segments with triangles. So next I want to talk about mid-segments with trapezoids. So keep in mind, a trapezoid is a quadrilateral with exactly 1 set of parallel lines, right? We already have parallel lines. The mid-segment is going to be parallel to the bases as well. Okay, so all 3 of those parts are going to be parallel. We can find the length of the mid-segment by finding the average of the bases. So we can take base 1 plus base 2, add together, divide by 2. That would give me the length of my mid-segment. Okay, so it's just the average of the bases, which kind of makes sense, right? If I had my hands along the side of the trapezoid and I squeezed it down, the top of my hands are coming out, right? So if I'm trying to make a rectangle so it's all the same, it makes sense. If my elbows have to come in, the tip of my fingers have to go out, right? So that's where the average comes from. So let's take a look at a couple of examples here. So let's start with B, since we're talking about the mid-segment length. Let's start with B. So we're trying to find the average for the 2 bases. So I'm going to take 10 plus 16 and divide that by 2. So 26 divided by 2 is 13. So the length of the mid-segment is 13. Okay, now keeping in mind that my bases are parallel and they're also parallel to my mid-segment, I still have all those special angle relationships again. Right? So what's the relationship between A and 55? They are congruent. What kind of angles are they? Begins with C again. Corresponding. Corresponding. These 2 angles are going to be congruent because they're corresponding. All right, so the next one, I'm going to teach you how to do it two different ways. We've done something very similar to this, so I'll link it back in a minute. But we know that the midsegment is equal to the average of the two bases, right? So my bases are x and 16. So x plus 16 divided by 2 should equal my midsegment, which is 22. All right, so multiply both sides by 2. I have x plus 16 equals 44. Right, subtract 16 gives me 28. Is that okay? Am I wrong? Okay? Okay. All right. But if you remember, when we were working with midpoints, the midpoint of a segment, we were finding the average of the x's, the average of the y's, right? And then we had to go and we had to find an endpoint. When we were given one endpoint in the midpoint, and I said there's a way to do it with logic. We can use that logic here as well, because we went from 16 to 22. And because we're finding the average of two numbers, 22 has to be exactly in the middle of those two numbers, right? So how much did it increase by going from 16 to 22? It increased by 6, right? Okay, well, we need to do that again if it's going to be exactly in the middle. So if I increase by 6, what's 22 plus 6? 28. So we can get that same answer. All right, you try the next two. You try the next two.
Maybe if we give them some time.
I guess. Yeah. Yeah. It'd be fine.
Some guys answer -5.
Next 5.
Easy, man.
Yeah, I want to
Try to get stick on this. Yeah. Yes. No one listens.
Does anyone need more time? We're good? All right, so for this first one here, we're almost done, guys. First one here, if we use logic, we increase by 4, which means I would need to increase by 4 again, and I get 13. Okay, now, is that one okay? Okay, so let me change this for a minute. What if I said, okay, let's let this be 9, let this be 5. What if I wanted to find x here? The reason I say this is make sure you're just thinking about the direction in that you're heading. So if I go from 9 to 5, I'm subtracting 4, so you would need to subtract 4 again. Is that okay? Both of the examples I gave you, we were adding, we were increasing every time, but you could be decreasing as well. Does that make sense? All right, next one here. So we know the midsegment, again, is the average of the bases. Right, so I need to add my bases together. So that's x minus 3 plus 2x minus 2. I have to divide that by 2 to equal x, midsegment. So I would clean that up first. Let's just combine our like terms. So I have 3x minus 5 over 2 equals x. I would then multiply both sides by 2. So I have 3x minus 5 equals 2x. I can subtract 2x, or I would subtract 2x. Just again, add 5, I have 5, so x is equal to 5. Is that all right? Questions on any of those? All right, so your homework, listen please. Your homework is out of your book today. I forgot to remind you that I was going to send it out in Word. I forgot. You can borrow a book today as long as it goes back. You will need your books tomorrow. Okay? You have plenty of time to get your homework done, so grab a book, get started, and get it done. Oh, you're not.